Hi guys, welcome to the stream. It's been a little while. My name is Will. I'm just going to do a little bit of housekeeping and then we're going to get straight into the stream. Just going to quickly share my link. I can't dual screen right now at the moment, unfortunately. So this might be a little distracting. Do forgive me. Okay, let's get straight into this. Just going to make sure my levels are okay. If anything with the levels are not correct, do let me know. Hopefully I'll be checking in and out of the chat if there's anyone watching live. And what else was I going to say? Yeah, totally forgot, lost my trail of thought. Just going to make sure everything's up and running. Yeah, everything's fine. Hi guys, welcome to the stream. My name is Will. I'm a freelance software developer. And yeah, I thought I would, kind of soft reboot things in a sense. I haven't been posting quite a while. It's been about a couple months or so. And I'm just really excited to get back into the swing of uploading onto YouTube. So I don't have much time right now in this particular morning here in the UK. It's about 6:30 because there's some things I need to do by the hour or just over in an hour. So worst case scenario, this stream is going to be like maybe half an hour to an hour long. I don't want to exceed that time limit. But I'm going to try and do my best to go through at least one or two of these walkthrough agenda points. So the whole premise of this stream is to kind of continue my 2D game development series, in particular featuring my Parallax Engine 2D, which you may or may not have seen on the channel featured in some of my videos. And all it is really, it's a Visual Studio C# Universal Windows project type. Universal Windows Platform project, rather, better said. And all it is, it's a framework that utilizes the Win2D runtime, which is a very neat library provided by Microsoft. And it allows you to develop very simple, lightweight 2D graphics, very fast, very efficient. And you can use this library to help leverage 2D games that you might want to build using C#. And, right now, everything is very, should I say, bare bones, because this is a very iterative process in that this Parallax Engine project, as it says here somewhere, I think I wrote it down or it's in the description, it's gone through a lot of updates and changes, and I wasn't really keen on keeping the, should I say, the vanilla prototype framework as it was. I really did set the groundwork, and I kind of saw the viable direction that I could take the framework. And so I started it again from scratch, and it will probably continue rebooting from scratch until I get a very, smooth and efficient code base to help give you a head start as a developer for if you say you want to develop 2D games using C# UWP and minimal middleware, in that there's no editor layer per se, although this is very extendable, so our editor layer could be implemented via XAML. But for now, I'm really focusing on implementing the code base using just C# with minimal like XAML editor layer stuff. And yeah, I'm going to just fire this up. It doesn't do much at the moment. Right now, this iteration of the Parallax engine, all it does, it just renders graphics. And I have some sample assets. And yeah, we're going to go through things, and let's just kick things off right away. I'm just going to double check this one more time. Let's see, let me go to my channel, just make sure the live stream is actually up and running. If anything cuts out, I will do my best to come back online. That's it there, and I think I should be good to go. Do let me know if anyone's watching live. If it's hard to read the text, I will do my best to zoom in. And I'm running this on my laptop, which isn't the fastest machine in the world, but I did upgrade it a little bit, so it is better than it has been before. So this is a very, very, and I stress extremely simple, example scene. And what it does so far, the render flow allows you to pass in graphics via sprite sheets, which I use the term sprite sheets very loosely. I am passing in PNG images, which I I got some like royalty-free graphics online, which I'm going to use as placeholders. And excuse me. And I'm going to go into this a little bit more. It's not the most efficient manner of passing individual sprite frames into memory. The thing you really want to do is actually kind of batch your sprites. If I can maybe find it. I think it's, if I go to my working directory, I think it's debug, apex, assets. If I go to my backgrounds folder, or actually rather my Archer folder, because I think that's a little Archer character. What you really want to do, and I'm going to touch on this as we go more into a little bit more in depth into the functionality, is if I pass, say, a sprite sheet as such, there is a way you can implement a cropping feature in the program at runtime, such that you can maybe pass, say, 10. Let's just say this is a 2 megabyte graphic, right? You crop each frame at runtime. You're effectively compressing what would be, what is essentially a 2 megabyte graphic, as opposed to like, and this what 1, 2, 3, 4, 5, 6, 7, 8 frames. If I were to individually pass 8 frames, these could be maybe like 1.5 megabytes each, depending on the fidelity of the image. And so that just means that I'm being less efficient by not sprite batching, but because I'm trying to do my best to just get a MVP, like a sort of minimal viable project out off the gate, I'm just passing each frame individually, and we're going to see how I'm doing that as well. So if I just quickly hop back to this, I don't think I program any controls as such. It's just a very simple animation here of the kind of Archer Samurai. I think that's a little samurai guy, but I really like the graphics on the website. I'll see if I can leave a link in the description, because where I obtain these assets, they're very high quality in my opinion for them being free, royalty free. But there are paid ones as well. I'll see if I can leave a link in the description after this stream. Very useful for me, and I'm sure if any of you are in the line of making 2D games, you'll find the website quite useful too, especially for placeholders. So this is all that there is right now. Very simple stuff, and we're going to just dive into what's actually happening. So I'm going to go ahead, minimize that, make some space here. So what we're going to do, the first thing I want to do to kind of illustrate this idea of interacting with a scene, with this idea of creating a video game. In this particular case, the Parallax engine sort of has a bias towards fighting games, and it's going to be conducive to really enhance the process of developing fighting games, in that I am looking to implement a input parsing system so that you can parse fighting, or should I say moveset commands. I've come from a traditional fighting game background, just generally speaking, in my illustrious career as a retired video gamer, and I know like a little bit about the mechanics of a fighting game and stuff like that. So if I can, say, provide some of those systems off the gate, it just means that if you pick up this Parallax Engine project type for UWP, you don't have to start from scratch. Like 20%, 40% of the work is already done, and you just build your game on top. That's the whole idea, the concept behind this Parallax Engine. So I want to implement, quite fundamentally, a player state machine. That means that the game will be sort of aware of if the character is running, walking, etc. Basic character movement, WASD kind of movements, and also having respective animations to the movement. So I'm going to see if there's time to get through all of these points. I think we'll probably be at best 2, because again, I only have like 30 minutes to an hour, so about like 7:30 max. I have to really wrap up, despite where I might be on the stream. And I just want to make sure the levels are okay. It's looking fine. And yeah, let's hop straight to things. So I think one good place to start is to kind of show you guys what is going on here. I know it says battle cards. This is just, I used like a previous project. I quite liked how I was, laying out some of the file structures. So I just continue building on top of this other project that I actually featured in a previous video. You may recognize it. So what am I doing here? Let's go to the main window .xaml.cs. This is kind of the main entry point. There's a lot of superfluous code here as I was experimenting, so don't get too distracted. But I'll do my best to kind of just, guide you guys through this walkthrough, this insight into how to approach making a 2D game framework with no editor layer, but just using Visual Studio and C#. So basically, using Win2D, you have access to what's known as the animated canvas control. And if I go to the Win2D documentation, which I think I have here, this is going to be your go-to if you want to kind of learn about the Win2D runtime and how to utilize the library in UWP. In this particular case, I'm using the C# flavor, not C++. And I'll see if I can find the animated canvas bit. So if we look here, for example, yeah, you can call on this drawing session property, and then you can call this, say, draw ellipse, draw text. There's also draw, I think, image is what I'm using, and you just fill the overloads. And it's a very simple process to actually render your graphics. And then it's a simple case of building around that to create the animations and such. So what am I doing here? In my XAML, I have what I've named the, I think, main animated canvas. Oh no, just animated canvas. It's over here. I'm not gonna jump to the designer view yet because it might take a bit of time. It might get a little bit laggy, but just know that the animated canvas control is here. And you want to call these three members, create resources, draw, and update. I've gone ahead and initialized these events at the constructor level of the main page. And it's quite important to create your resources first before you start to construct your draw and update loops. Because what tends to happen is the way Win2D works is that if you're calling your draw loop, and you're referencing resources that haven't actually been loaded yet, you'll end up with an exception, and that has happened to me in the past. So what I tend to do is I make sure that I call this I set this create resources event, which is hooked to this generate resources function, which I have placed in, I think it's load animated resources, but I have this folder structure loosely referencing the MVC architecture, but it's really just a folder structure for me to keep things a little bit more neat. So I don't know if it's in the model. I don't think so. It would be in the view if I'm not mistaken. Yeah. So load animated resources, generate resources, and the way this works, all this function does, I have to zoom out just to make it easier for me to see. I have this concept of sprite sheets, right? And I want to populate these sprite sheets such that I can dynamically access each frame that I need to render on the screen at runtime with no issues. And so what I do, I'm going to also illustrate this idea here. So I'm gonna make like a notes section because it would really help if I just illustrate the idea as I'm talking through. I'll just quickly make a little section here just so we can follow through. So if you imagine, I have a list of type, I think it's a string, I'm not too sure, but it's a list of list. Just gonna double check I got it right. No, so it's a list of canvas bitmap, or was it string? Because I have a list of file paths, but I don't want to jump ahead of myself. Let me just have a double check here. Yeah, so let's start with this. So I have a list of string, right? And let's just call this file path master list because it's a list of lists. It can get a little bit confusing to get your hand around, but it does make sense as you go along with this. So let me spread that a little bit. No, that's fine. And what I'm doing in this list of lists is that I'm saying, okay, if in this outer nested list I have, say, X amount of elements, and each element here is actually a list in itself. And in each list, and in that nested list, it holds strings, okay? So we can have string element 1, yeah, let's do it like this, 2, 3, such and so forth, as many elements as we want to add inside our list of lists. And the thing is, these frames, these elements in the nested list actually represent our sprite sheet frames. And the reason that I am doing it as a list of lists, it's just so that each row could be utilized depending on me, the developer, or yourself. If you, let's say you use this framework or you're using it, hypothetically speaking, if you wanted to say structure your framework such that each row represents a full-on sprite sheet for, say, a character in your fighting game, then each element in the row could be a frame. You could have an idle animation of 4 frames. You could have maybe an NPC with, like, let's say 10 frames of animation. And you can just use simple loops and indexes to access each element as you need in the program dynamically. And it makes things very streamlined. It helps to extend and modify the program. I found it really helps for literally just updating things without having to just get too stuck in. It's very interesting stuff. So that's what I'm doing in my main function in the generate resources. You'll see that I have this sprite local file path list, right? Which is the list of lists as I've just demonstrated here. And for the range of its count, okay, I am adding a new entry into the canvas bitmap list. So if we go to canvas bitmap list, it is another list of lists. And it sort of mirrors this file path list of lists. The only difference being that this canvas bitmap list holds this class, which is a canvas bitmap, and this is the bitmap information that Win2D uses to render graphics, bitmap graphics. And what I've done is that these two lists, the canvas bitmap list and the sprite path list, they mirror each other. So if you access, say, an element at index 10, it pertains to the element at index 10 in the respective bitmap list. So it kind of works together with each other. Because what ends up happening is that you need to load from file in this particular structure. You need to load from file, as I have here, the Archer folder directory, and then you need to actually reference which asset you need to load at runtime. In this case, even though it's not really named correctly, and by that I mean I have idle animations here, but it's titled run_5 all the way to run_8. It really should be idle, but because I know what I'm doing as I'm programming, it makes sense to me, but I really should update that. I did it for speed. There's a naming convention as well I'll touch upon, why I've kept the naming convention very generic and simple. So anyway, let's take a sip of my tea. It's fairly early. I feel a bit groggy, so I need some tea. Excuse me, sorry. And so what I'm doing, I'm saying, okay, I want to loop through this list, and I want to add, let's see what we're doing. Oh, yes, and I want to load a bitmap graphic in memory. Okay? And to do that, I'm basically calling the load async method from the canvas bitmap class. I'm referencing the animated canvas, so like the target control on the UI that I want to display the graphic on, and I'm referencing the file path list of list. Now here, the file path list of list would have already been populated because I'm accessing the file paths via index. So I'm going to go, I think that bit is somewhere else. I'm going to try and find it. Yeah, it's just here. And it's a very similar approach. So what I've done to load this, so basically to load the list of lists holding the file paths that will then subsequently be used to populate another list of bitmap information. I have a little bit of a pipeline here. Don't worry about the ones underlined in green. They're not being called at the moment. So I'm loading. I could have used loops for this, but I decided to just go with a pipeline sequential approach so that it makes it a little bit easier to read and to just deal with. So what I'm doing, I have a local function, boom, load Archer, okay? So this is pertaining to loading the Archer assets. And so I know already I have X amount of frames for my Archer assets for a particular sprite sheet moveset, like animation frame. In particular, let's say, for example, I I have here this samurai full sprite sheet member, which is in an enumerated list, actually has a value of 9. If I go to its definition, what I opted to do is to say, okay, if I know my samurai, which is this little samurai asset guy here, has 9 frames for a particular piece of animation, I'm going to store that as an enumerated value so I can access it very easily. I'm using that as a range, and I'm incrementing the index. And all I'm doing is I'm saying, okay, for each frame, I want to add to my sprite file path list of lists, the inner nesting. I want to access my working directory. Here's my file path, assets archer run underscore, and this is where the generic numbering comes in handy. As long as you name the naming convention is predictable and generic with a number suffix, and by suffix I mean like at the end of the so I have 0, 1, 2, 3, so on and so forth. It just means that I can basically just concatenate this value as a I can concatenate this value, convert it to a 2-string, and add it to my directory file path string, so that I can just very easily iterate through all of these files, and I can just access the file paths I need without having to hard code them all one by one. So as you can see, I have one line of code that performs this add functionality, but because it's dynamically programmed such that it will go through this directory, it will then add every file that begins with run underscore, so run underscore, and then ends in the value of index as a string will be loaded. So that's that. I've kind of encapsulated that functionality in the local function. Load icecap stage is the same kind of concept, but it's for the background. So exact same thing, but I'm going to a different folder, the backgrounds folder. See if I can show you guys. I go back, go to backgrounds, and then as you can see, I have icecap underscore 0, which is kind of a nice icecap background. And I'm loading that in the sprite file path list. And then what am I doing here? Yeah, I'm adding to the list. Yeah. So my outer nesting, I'm adding a new list entry. So for each, let's see, I'll make sure I'm doing this right. Yeah, so for each set of frames, I'm adding a new list, as you can see. So adding a new one. It depends on how I want to structure things. So in this case, I've only loaded the ice cap background and the archer animations as 2 separate entries in the lists. And that's all for that. And in as much as you need to load assets, all you got to do is just follow this convention. So what we're going to do, if there's time, I only have about half an hour left, is if I want to load running animations, which I already have prepared for the archer, which again, not very conveniently named because it says run, so I guess it makes sense. I have left and right running. So from run 0 to run 4 is running to the right. And then from run 9 to run underscore 13 is running to the left. We can make use of this. So that's that. Just to kind of bring you guys up to speed with what's going on. And then again, I have this draw class, which is in my models folder. And this is where a lot of the magic happens. I have a draw loop. I have a draw loop, which I'm trying to find now. Yeah, it's my animated draw function. And in the animated draw function, as long as you've initialized your animated canvas correctly, you should have these arguments: send this iCanvas animated control and canvas animated draw event args. Now, if you call the canvas animated draw event args, it gives you access to a few members, which allows you to render graphics. So I have a bit of again, another pipeline here. The render flow is as such. I implement physics, so any kind of simulated physics. So, for example, if I quickly run the program, a couple seconds hopefully, the samurai, I believe he actually drops down slowly and stops. That's because I programmed a sort of gravity functionality, so the samurai kind of drops down into view. But then I also have a ground plane in that when the character bounds, and I use rectangle or rect structs for the bounds of the assets. When it collides with the ground plane, then it's upthrust, as you can see. I was referencing some wrong frames there. I was seeing some of the running animation. I had to make sure everything's correct there. But if you looked carefully on the screen, I'm going to show you that one more time. The samurai actually falls from his default position in the sky, as it were, and falls onto the ground, as it were. So I'm going to show you that again. It's a bit fast, so you have to kind of look closely, right like that. And then we have our kind of simulated gravity. So that's what's going on here. This physics is just a local function. I'm going to expand it here. And all I'm doing, I am referencing, I'm calling this gravity function, which I have in the physics class, which you can find here in the models folder. And in the physics class, I have this gravity function. And all it does, it returns a y position post-incremented by some force. And this force simulates gravity. I've given it a value of, I think, 12. Which kind of pertains to the speed. And upthrust, again, returns the y position, but as a counterbalance, it's a post-decrement of the same amount of force. And because the down force is being post-decremented, after it's being post-incremented as such, it actually cancels out, and that's why the samurai stays still after he's hit the ground, kind of thing. Okay? So fairly simple at the moment. I'm going to just collapse this local function. Animate sprites. This is what I do to animate the samurai. As you can see, when he was idle, he was moving around a bit because I loaded a few frames of animation. Now, I thought the most efficient way to do this for my Parallax engine here is the first thing I'm going to draw your attention to is that I'm calling E, which is my the argument for my canvas animated draw event args class here. Passing it as E. I'm accessing the drawing session property, accessing the draw image method, and the fun thing that I'm doing here, the overload I'm invoking is, let's see if I can find it. I'm in the wrong place. There's quite a lot of overloads. It's 19. I'm simply using the overload where you pass a canvas bitmap and a destination rect. So the canvas bitmap represents the bitmap information you want to render, and the destination rect represents the bounds on the screen where you want to place your graphic, the dimensions and its position. So what I've gone ahead and done is that I created a function called animate sprites, and this is what helps me to update sprite animations without having to reinvent the wheel all the time, or to avoid hard coding in as much as I can. This animate sprites function, all it does is that it says, okay, give me a list of sprites, so a collection of frames. Give me the speed at which you want me to animate the frames, and give me a lower and upper limit to target, and I will animate those frames only. So let's say, for example, I passed in, okay, a list here. Let's just say this one, and I will target frames 2, 3, and 4. I pass the lower limit 2 into this functionality, into this function here, as a frame lower index. I pass 4 as an argument for the index upper. And I wrote some code such that it will literally just animate those frames. It will render those frames on the screen and ignore every other frame in the list. That's what all of this is doing. So all this logic, I'm not going to go through it like line for line because, again, I don't have a lot of time and it's not really too necessary. That's what all of this does. And then I return a canvas bitmap graphic. So I'm going to go back. Actually, I'm just going to hop to my draw function. And yeah, that's what's going on here. So when the draw image function actually is asking for a canvas bitmap, that's what I'm doing. I'm returning a canvas bitmap dynamically at every draw loop, and it's updating pertaining to the animation that we need at runtime. So that's what's going on there. And yeah, it's quite good because I can reuse that animation function for any other asset I need to place on the scene. And yeah, that's what I do for the background as well. So even though that background doesn't animate per se, I am passing it through this. Actually, am I passing it through that functionality? I don't think I am actually, which I shouldn't be. I should be doing. I even made a note of it. So yeah, what I'm doing is, in this case, which is fine, I'm actually just passing that one frame on its own which is I'm actually referencing that graphic itself in the list directly because I didn't see a need to animate it per se, but really I should be doing it that way, just to keep things consistent. I thought I actually updated that. I'm not too sure why it's like that. I even made a note somewhere. I think maybe I deleted it. I'm not too sure. But that's the overall render flow that's going on here. I'll close the space here a little bit. So again, I'm just glossing over things before we start adding some functionality. The reason we want to play a state machine, it just makes it easier for us to kind of know what's going on and to process movement, for example. Speaking of which, if I draw your attention to this controllers class, I have an input parser. And all it does, what I'm going to do to demonstrate this, I am going to put a break on this if statement, which checks for the A key being pressed. So all this input parser class does, it checks for keyboard and eventually it will check for gamepad control. I have functionality. I think I made a note of it here somewhere from one of my previous iterations of the Parallax engine. What you see here is this class, all it does, it initializes a PC controller, which could be an Xbox controller or any PC compliant controller, whether it's Xbox, Microsoft, or a third-party one. As long as it's supported, this init controller function will actually initialize the controller, and you can enumerate through the connected controllers at runtime, and you can even program for multiple controllers if I'm not mistaken. But I've only really programmed for one controller at a time. But for this, because I don't have access to a controller right now, I'm just using keyboard inputs via the core window, I think the core window class. So what I'm going to do, I'm just going to quickly demonstrate this. Yeah, it's on A, the A key. So I'm going to hit A at runtime, and it should break to that line of code just to show you guys what's going on. I hope the sound level is okay. And yes, resolution scaling isn't really optimized. I will maximize it just for the sake of showing you guys. But it's not really optimal. Nothing's really optimal here right now. But it doesn't really matter. And I kind of like it windowed for now. It's just easy to look at. So if I just hit W, nothing happens SD. If I hit A, as you can see, it breaks to this line of code because this is evaluated for true. This key down is evaluated for true against the virtual key .A. This A key here. And so what I can do now, what I've actually done already, is that I have this member called state, and it's stored, it is assigned a value player of this enumeration list value left. So I have this enumerated list called player state. If I go to its definition, and this enum holds left, right, up, and down values. Really they're ints, but it's, you know, just for readability, left, right, up, and down. And so now I can say, okay, I know that I've opted to go left, even though with A, I should be going left. Sorry, I didn't know my WASD for a second there. So I can kind of use this state machine to sort of, you know, present myself with a scenario where I can process movement on the screen, very rudimentary movement, as long as I can access this member within a scope that I need. And the scope will happen to be in the draw core probably, or the update loop. I'm going to see what's best. I think it'll be the draw core because it's quite cohesive with the render functionality. Really, this should probably be in its own class, but it's in the input parser. So all I'm going to do is just make it public for now. Access it publicly, out of scope if I have to. And obviously, once I get the functionality working, I can optimize it by passing it in its own, probably like within a static context, I think would be best as well. That might be something to think about too. So, you know, that works. So I think that's enough glossing over for now. I'm going to spend the next 10 to 20 minutes seeing if I can do these two. We already have a sort of player state machine actually via this state member. So all we have to do now is look at this state member, look at what it's saying, and execute the according character movement. So I have left, right, up, and down. I think I should also add to the idle. Add idle to that state. What would constitute as an idle state is interesting. I want to know what the key down value is. what would it be at neutral? I'm just going to check something quickly. Just kind of glossing in my mind the best way to implement a idle state. I guess for one way you can go about it is if all of these conditions evaluate for false, then I could result in a contingency where the state just defaults to idle. I guess that could work as well. So what I'll do, again, this is not all optimized, but what I'm gonna do is I'm not even gonna evaluate. I'm gonna set the state to idle, the character state. And in this particular case, I'm going to set it to this state to a particular value. Let's say it can be any key on the keyboard, but it has to be one that doesn't really interfere with the gameplay pertaining to movement. But first, I'll just set this to idle. I don't even know if I'm processing this right, because really the key down state will, because I'm just worried that if I don't update the key down, there might be conflicts in the state such that, let's say I press down the D key down changes, but when I hit the idle state, I also want the key down to reflect that change. So I guess the key selecting now is kind of a null key. I'll just see if escape is there. Let's use escape for now. And so if we are debugging and we see the virtual key is escape at the moment, then we know we are effectively in idle state. Let's do it like that for now. Okay. Like this. And I'm thinking if it's worth returning after each true evaluation. And I mean, if you're talking about, you know, WASD movement, you're not going, because that's a digital input, it's like you're not going to have two inputs in one call, in one loop. If you press W, you won't be pressing A at the same time, S or D at the same time, depending on the situation. In this case, if you're turning left and right, there isn't really a state where you are going left and right at the same time. So with that being said, I think it's safe to return at the end of each of these evaluations. And what will happen is that if this doesn't return, then it will default to this code, which will then set the state to idle. If my logic is sound here. And then so there are two scenarios I want to take into account. The actual underlying action happening on the screen, idle movement, etc., and the actual animation itself pertaining to the action on the screen. I'm going to quickly look at this physics functionality. So what I'm going to do, I'm going to start making use of the state machine by checking for player state before I execute the appropriate action. So for example, if I reference my main page, which I think instantiates the movement-parser, as long as I made my state member public, I can access it now. And I can say if I can check the state for that's the thing, I don't have an airborne state actually. I only have up, down, left, right, idle. But I guess you can have airborne because you only want gravity to kind of affect the player only if he or she is airborne, I guess. But it really depends on how you look at it and how you program the game. I'm not going to program an airborne state for now because of time, but I know later down the line I will need it because in the context of what I'm trying to go for here, is to just give you a little bit of background. I play the game a lot of Marvel versus games, Marvel versus Capcom kind of style games, and obviously in those kind of games you can move in the air, left and right, up and down, and stuff like that. So I think it won't go amiss to have a kind of an airborne player state, but I don't think I'm just there yet. So all I'm gonna do, this check here is for up thrust. That's fine. I'm just gonna leave it as it is. What I'm really concerned with is the ground movement itself. Okay, so here's what I'm going to do. I'm going to check for player state, namely left, right movement. And then what I'm going to do, accordingly, I'm going to translate the player across the scene, depending if the player samurai needs to move left or right. So again, main page reference, my physics class, sorry, input parser. So if state is say left, i.e. if I'm hitting A on the keyboard, oops. So I'll just make a note here. So I'm checking for left movement. And this actually touches upon camera programming, which I don't think is going to be covered in this video, but it would definitely be an important topic to cover soon. Because obviously I want support for this framework to, provide parallax camera movement, as it were. All right, so I'm going to call a functionality here called translate, which I haven't created yet. It's going to be in the physics class. So I'm going to go into my model namespace. I'm going to go to the physics class. I'm going to just simply say public double, and it's going to work quite similar to up thrust and gravity in that I'm just returning a value, which I'm then passing to the bounding rect structure, and that just is reconstructed, and it just basically, just as you saw the samurai go down when I started the game, the samurai will go left and right instead, depending on the state machine. So it's going to be very similar to this. I'm going to say something like translate player. It's going to take as an argument X position. And I'm just going to return a value. I'm going to return X position. I'm probably going to need another argument. This will be the state machine. Let me just double check this. Because I don't have a reference to the main, but those states are effectively ints, I think, in the enumerated list. So let's say, for example, let's see what happens. Let's see if I got this. I go to input parser, excuse me, and I go to left. So left is effectively 0. Fair enough. If I go back to physics and I say, okay, if state is the same as 0, the value basically, I want to move to the left. So to translate the player to the left, I need to post decrement the value. That's how this environment works. So I'm going to post decrement by value. Let's just say run speed. And run speed is just going to be a double in global scope here. Oh, neck. Double, can't read. 14, let's make it a bit fast. That's correct. Oh yeah, not all code paths return a value. Let's get rid of that for now. Let's return state. Okay, so and I think running to the right might be 1 or 2. Let me just double check that. Right is 1, so if I go back to the physics class, I could say, I'll just copy and paste this. So if that enumerator list value of the state is 1, then instead I'm going to post increment rather than post decrement, and I'm going to return state. I'm going to reference this. I think it's in the draw class. Main page ref. And physics. Translate player. Gonna pass my parameters. So state, the current state of the player. Again, main page ref. Input parser. State. Let's see if that's correct. Yeah, that should be fine. An X position, and the way I'm keeping track of the position of the player is via bounding recs. So I can say something like, I have a rect struct already constructed called player1 rect, but it wants us the position of the X value as a double. So I'm going to access the double property, or the X property rather. Yeah, I thought this would happen. So what I'm going to do is, let's see, state. Probably can just cast this. Hopefully that'll cast the value as an int. I'm not too sure. I have to test it out to see if it works. So what should be happening, if this is all correct, then this will return a value. Namely, it will affect the value of the X position of the player1 rect. Yeah, that's fine. And then all I'm going to do, at every draw call, I'm just going to reconstruct the rect, and it should update accordingly, hopefully. So if I go ahead, collapse this for now, I'm going to animate sprites. Yeah, and I'm already intuitively... Wait, let me see what I'm doing here. Yeah, I'm already intuitively constructing the rect at every draw call. One thing to note is that I need a an appropriate dispose functionality, because if I'm constructing a rect at every draw call, I'm gonna have superfluous rect structs not being used after every call. And the thing is, if I don't do this, the graphics don't seem to update in terms of the underlying rect values do update, but the render didn't update as such. So I ended up just constructing the rect again, and that solved the issue. But then that will give me some memory issues. I don't have the diagnostic session up. I can see something here saying diagnostic tools. I'm a little reluctant to click it because sometimes the diagnostic section in Visual Studio is a bit slow. But I'm pretty sure that there's going to be issues with performance if I don't have a good disposal resource disposal system in place. But again, that's all going to be coming with time. So yeah, let's kind of test out where we are right now. I do have to wrap this up in like 10 minutes because there's something quite important I need to do after this. Maybe I'll do another stream later today that's a bit more extended. Let's see. Yeah, let's just click that, see what happens. Let's see if the samurai will move to the left or if anything will happen. If not, I'll have to just debug and see what's going on. Make sure my levels are there. Okay, so the samurai is into the screen. Gonna hit A. Okay, nothing seems to happen, which is fine. Let's see. Where's my input parser? Anyway, can't see it. Let's check the history here. I guess my guess is that I'm falling through to this idle state or something, but I should really just be debugging this thing. But I think I know what's going on. Actually, I don't know. I'm not going to claim that I know if I don't know. Let's hit A. Yep, I'm here. Change the state. State is assigned left. Return. And what I also want to do is go to my draw functionality. I'm going to put a break here. I'm going to step out. Physics. And expose this functionality. Gravity. The gravity is fine. What we want is this. Check for left movement. So I'm going to step out to this. This is evaluated for true, so state is indeed left. It knows that. It's been acknowledged. I'm calling translate player, so I'm going to go into that. If state is 0, so X position is 80 right now, so the samurai is at 80. Post decrement the run speed, so minus equals 14. So yeah, we're on 66, and that should be returned. So if we go to player rect, oh, that's very fascinating. I guess I'm just not assigning it the value properly. So if I just go to this, and I just make a simple assignment, that might fix the issue, I'm not too sure. Let's hope we can just continue evaluating this. And then get rid of that break and just evaluate what's going on. Before I do that, I'm going to step through this again. So I'm on 80. I post decrement 66. I'm going to check the value. 66, I'm going to check my rect. Yeah, so now it's updated to 66. I'm going to get rid of that break. And I'm going to continue, see what happens. I'm going to hit A. Oops, I'm going to get rid of this. So we can kind of just see what's going on. Still nothing's going on. Okay, fine. So the underlying data seems to be updated correctly, but there's still no update on the screen. So what I'm going to do, go back to the draw function, or the draw class rather. I'm going to go to animate sprite, and this is where the updating is happening. I'll put a break there. I see that this value is back to 80, and we've got to figure out why. So this player 1 rect, which if you can see closely, I don't know how sharp the resolution is on your screen, is 66 for the X position. I'm constructing a new rect. That's the issue, I think. So what I'm going to do, I'm not too sure why I'm passing for the X value this property, which is obviously hard-coded because it's a default value of 80, then that's the issue. So instead of this hard-coded default value, I'm going to pass the updated rect value. So I'm going to pass this. Hopefully it's correct what I'm doing. Access the X property. And similarly, I'm going to access that here. Hopefully this is correct. Because what should happen by default as well when I construct this rect, its default value is 80, as you can see here. So there shouldn't be an issue upon initialization. So if that's all well and good, I'm going to continue and just kind of evaluate what's going on. And the Samurai is off screen, which is it's a good sign. Samurai probably just went off screen because if it worked, the Samurai went to the left off screen, but it didn't update for idle. Funnily enough, probably because it's still evaluating for the key being pressed down. So that's something I need to update. Okay, that's interesting stuff. Alright, so it seems to be evaluating for A for some reason. Not too sure why. I'm gonna just double check what's going on my render flow. It seems to be evaluating for left. If we go to my input parser, this shouldn't be, I shouldn't be hitting this. So if this evaluates while I'm not touching anything, even though the commenting is incorrect, then if this does evaluate, something's obviously wrong. But I think it's somewhere else the issue is. Yeah, so I'm setting values wrong somewhere else. So I'm going to go to the draw class. I'm going to make sure this is not tripping, which it is. That's very fascinating. Maybe I've put this on a default position of left and it should be defaulting to idle. That's why there's an issue. Where is my input parser? Where am I initializing this to? I find that very fascinating. Seeing as maybe it's because this is the first entry, so I'm not too sure if this is going to make a difference. But I'm going to force this into idle state by default, just to be safe. I'm a little skeptical, but I'm going to just try it anyway. If not, I'm going to expose all references, see where this is being assigned to left, and just make sure that I'm not assigning to left out of place. Sweetness. Okay, so we fixed the issue. So it was just that the default state was actually, in fact, left. It should have been idle. And I think this is, I'm going to do one more thing just before I continue. I don't want to kind of confuse things, but it's not evaluating gravity because of the state. The state is not evaluating for idle. It really should be like an airborne state, but for the sake of argument, I'm going to evaluate for idle, even for gravity, the effect of gravity. We'll go here. Gravity is being imposed somewhere here. I'm trying to find it. Right here, okay. Just make sure this is correct. Oh well, there's no preconditions encapsulating this, so I don't know why the gravity is not working right now. I'm going to double check that later. So the main thing I want to check is the left, is the translate button, or the translate feature, the translate functionality. And because I'm very conscious of the time, I'm hoping this works, because I might have to wrap up here, because there is something I have to do quite important in the next 5 minutes. So regardless, in the next couple of minutes, I'm going to wrap the stream up. It works. So we do have some action here. And yeah, the camera just moved off screen. I just barely saw the camera move. I'm gonna just restart this. So I'm gonna just move this a little bit. Okay, as you can see, the player translates off the screen to the left. There's not a lot of time for me to go over the actual pertaining animation, respective animation, better said. But I will see if I can come back online today, either in a pre-recorded video or another stream continuing this. I can definitely cover more ground in a single video because I can use editing, but I do like these kind of straight ahead live streams. They're quite insightful, quite fun to do as well. So guys, I'm really glad and I'm grateful for anyone who may have tuned in for the stream. Hit me up on LinkedIn. There's information in the description, and keep up to date with the Parallax Engine. It's a very interesting project. Excuse me. My name is Will. I hope to see you next time. Take care. Bye bye. Gonna close the stream now.